complete diagram again. Now you can see the mixture tube, the 12SA7, feeding into the IF transformer. Now, IF transformers have a primary and a secondary. They're both similar type of windings, and they're both tuned. They either have a powdered iron core that you can screw in and out of the primary, and another one that you can screw in and out for the secondary. Or if they don't have that, they have two little variable condensers that you can adjust with a screwdriver. Either way, it amounts to the same thing. You tune up the IF coil to the 455 kilocycles. From there, it enters into the first grid of the 12SK7, pin 4. Now you'll notice on the 12SK7, the signal comes in number 4, and to prevent feedback, it's taken out pin 8, which is the opposite side of the tube. They wouldn't want to take it out pin 5 and put it in 4 and take it out pin 5. They take it from the opposite side of the tube, so there's no feedback. And if you get feedback, you get whistling and oscillation. Now, the 12SK7 amplifies the IF signal, and it feeds it into the second IF transformer. Now, the second IF transformer is tuned in a similar manner to the first one. So now we see we have a total of 4 tuned circuits, all tuned to 455 kilocycles. The other signals just won't pass through. They are eliminated. After the signal comes out of the second IF transformer, it has to be detected. And the 12SQ7 is called a diode detector and triode audio amplifier. The diode is just a little tiny plate, which is pin 4. Actually, there's 2 diodes in there, pin 4 and 5. And pin 5 isn't used, but they got it tied over to AVC. But it wouldn't matter. You could just snip it off and ground it or something. So the diode load consists of the volume control, which is a 1 meg. And there will be a large negative voltage appearing on the volume control. This is because the diode is a rectifier. It rectifies the amplified IF signal, and the negative voltage will appear on the diode load, which is the volume control. And it can be as high as 20 volts or so on a strong local station. And it's always a negative going voltage. Now that voltage is taken, I'm going to put another diagram on. There you can see the volume control, but you'll see another resistor above the volume control. So the signal from the diode detector has to go through a 47K resistor, then into the volume control, and then to ground. You'll see 250 condensers there, 150 picofarads. They're very small condensers, and their purpose is to, if there's any IF frequencies remaining on that line going to the volume control, that they be bypassed to ground and eliminated. So all we have left is the carrier of the station and the audio signal. Now you'll see that the bottom end of the IF transformer, where it's connected to that 150 picofarad condenser, also goes along to the left and down to a 2.2 meg resistor. So we're taking some of that negative voltage and we're feeding it through that 2.2 meg resistor. Usually you lose voltage when you run power through a resistor, but in this case we don't. If we start with minus 10 volts, we should end up with minus 10 volts. It may not read minus 10 volts on your meter because your test meter may not be sensitive enough. It may measure like minus 8 volts or something. Anyways, that the negative voltage is filtered to smooth it out, because it's got audio in it, by the 0.05 condenser. Right here. That also keeps the low end of the secondary of the first IF transformer at ground potential. That voltage is AVC voltage, is called, that's what it's called, and it's also fed over to the antenna coil. In this case we don't have a loop, we have an antenna coil, and it's fed into the antenna coil, and it goes up and supplies negative bias on pin 7 of the 12E6. So AVC is fed into two stages, the mixer oscillator stage and into the IF amplifier stage. This prevents overloading on strong stations and opens the tube up to full amplification on weak signals. So when you dial in different stations, there isn't the difference in volume like there used to be on the old time radios, where every time you change station you had to readjust the volume control. Going down to the volume control, we have the arm, which is an arrow there. It's not a very good arrow, but it picks off the amount of audio that you want, feeds it through a capacitor, a 0.0047, and it feeds it into the grid of the 12AV6. Now, the 12AV6 grid is biased the same way as the oscillator was biased, by capacitor 0047 and the grid leak 4.7 meg. And notice the difference in values compared to the oscillator, because signals are weaker here in the audio level, and as you turn the audio up and you get louder, you get more bias. And that system works fairly good. If you increase that 4.7 to 10 megs and turn the volume up full, it'll sometimes cause the 12AV6 to start to choke off because it's getting too much bias. So 4.7 meg works the best. Up on the plate of the 12AV6, the audio is now amplified and is stronger. And there is another capacitor there, a 330. That's another bypass in case those 250s over by the volume control didn't get rid of any IF frequencies, or some frequencies got carried between the diode and the grid, and RF can appear on the plate of the 12AV6, or IF frequencies rather. And of course, that little capacitor there, which is a 330, bypasses them to ground. On the plate is another resistor, fairly large value resistor, 270,000. That supplies the B plus up to the plate there, and the B plus usually runs around 60 to 70 volts if you measure it. From there, the audio is coupled through a coupling capacitor, 0.02, down into the grid of the 50C5. And there is a grid load on the 50C5 of 470K. Now this is not a grid leak bias, but we still have to have a grid leak there to stop any grid leak bias from forming. The bias for the 50C5 comes from pin number 1. You'll see pin number 1 to ground is 150 ohms. And that will develop about 8 volts. So you have the cathode at 8 volts more positive than the grid. So that means that the grid is 8 volts negative compared to the cathode. So that supplies negative voltage for bias, or positive voltage for bias on the cathode of the 50C5. It's always positive voltage. And in some sets, you will see a electrolytic bypass condenser across that resistor. If you put a bypass across that resistor, you will get more volume, but you might get a little bit more distortion, because having that resistor unbypassed is what is known as negative feedback. And negative feedback cancels out distortion. So if there's some distortion going to be produced in the 50C5, having that resistor unbypassed would be a little bit better. Notice the plate of the 50C5 goes over into the output transformer. And the bottom end of the output transformer is fed right off the rectifier tube. That gets a full voltage, probably 135 volts. The 1200 ohm resistor reduces that voltage down to about 90 volts, 95 volts or so for the other tubes. So the highest voltage is going to be found on the plate of the 50C5. You'll notice another condenser across the output transformer. Now that condenser has to go from plate to some kind of a ground potential, and that is grounded through the filter condenser, or that condenser could be connected over to the cathode, or it could be connected to ground. It doesn't matter, it'll work either place. And the purpose of that condenser is to, if there's any IF frequencies still coming through after all those other filters, that'll clean them up from getting into the speaker. And it also smooths the tone out so the tone isn't so harsh. The secondary of the output transformer feeds the loudspeaker, and you can ground that to the chassis. I wouldn't put it to the floating ground because you wouldn't want AC on the chassis, on the speaker. So we just hook it to the chassis, and that pretty well completes the circuit. The circuit is about the same. It doesn't matter which tubes you use. The older sets use the 12SA7, 12SK7, 12SQ7, 50L6, and 35Z5. This is a newer circuit, but other than that, the circuit is about the same. Now the first sets used to have a field coil in the speaker, and everything from the rectifier tube over here from pin 7 on the 35W4, everything went through the field coil, and there was a filter from each side of the field coil to floating ground. This helped smooth out the DC, and they had smaller filters in those days, probably 20s instead of 47s, and they eliminated some of the hum by using the speaker field as a choke. It also magnetized the speaker field and allowed the speaker to work. And when they got rid of the speaker field, they had to put that 1200 ohm resistor in there to drop the voltage down to about 95 volts. The speaker fields, they were used until they invented the Alnico magnet and got it working, and this would be around 1939. The speaker fields disappeared. The speakers that had the Alnico magnet were actually lighter than the speakers that had the field coil, because the field coil was quite massive, contained thousands of feet of fine wire, and it had a little bit of weight to it. Here's a circuit of the audio system. We can just run through that again a little bit. You'll see the last IF connected to one diode, the other diode grounded to the cathode. I left a little wire out right here between the cathode and that ground mark. And you'll see that 47K resistor, which is an IF filter to keep the IF out of the volume control, and the 250 bypass capacitors. Over to the left is the 2.2 meg resistor and a bypass condenser 05 making the AVC line. Now you see from the volume control, we go through C1 0047 and your grid leak resistor 4.7 meg. C2 is the 330, that's another IF bypass in case there's any IF signals on the plate circuit of the 12AV6. Coupled over through a 0.02 into the 50C5. Now I have to tell you about coupling capacitors. C1 and C3, 0047 and 0.02. Sometimes it was just a 0.01. They were very, very troublesome, especially C3. Not only did they leak voltage through to the grid of the 50C5, they also became intermittent. The little wire inside them was soldered to the tin foil, and it always had a habit of becoming unsoldered, and sometimes it would connect and sometimes it wouldn't. And of course, if it didn't connect, the audio went down, and as soon as you went to turn the volume up a little higher, it all of a sudden came on full blast again. So that condenser, if you ever see one in one of those radios, and it's an old type paper condenser, get rid of it fast. The three main condensers that suffer from leakage is C1, C3, and over here at the ABC there's a .05 bypass. Those are all sensitive to any kind of leakage, and if they're old type of condensers, I always change those three. I usually change the whole works, but I always start with those three. The one up on the plate of the 50C5 is a .02. It can sometimes short, and of course if it shorts you don't get any audio, or not much audio anyway, depending how bad it shorts. Now another trouble we have, I'll put this circuit back on. Here's a good test that you can do when you fix one of these radios. After you get the radio fixed and working good, you tune it into a weak station like Calgary or something, turn the volume up fairly high so you can hear it, and then go carefully and take one IF coil at a time and just wiggle it back and forth slightly. If the station changes level, you'll know that that IF coil is defective. And they are very prone to doing that. Not the ones with the two screws in the top, but the ones that have the iron cord slugs. They have little mica condensers down inside the IF coil, soldered across the coils. You can see them there. There's four of them, one on each coil. They're just a little piece of mica, and they are sprayed with, probably sprayed in a vacuum with some kind of a metallic spray, and they're sprayed on both sides of the mica, and then they are put into a little clamp in the IF coil, and that presses them for contact. One little brass clamp on each side of the capacitor, and over a period of time, heat expansion and so on, the plastic moves, or the mica moves a little bit, and some of that metallic surface wears away, and some of it gets tarnished. The little brass finger that presses against it can get tarnished, and you get an intermittent IF, which won't show up on a local station very much, but it surely will on a weak station. And the solution then is to change the IF coil, if you can find one. Now if you get one out of another radio, you might just be going from bad to worse, because anything that's 40 or 50 years old, you never know how good it's going to work. And I don't know if you can still buy a new IF transformers or not. I personally take them apart, and I take those little capacitors out, break off the little fingers, and I solder a little silver mica across each coil, about a 50 picofarad. And it's a very touchy job. You need good eyesight, you need a little soldering iron, you need to be very steady, and you have to be quite patient and very careful not to damage any of the wires coming from those coils. But you can change those capacitors if you're good at that kind of work. It's not easy to do. Now, about alignment. If you want to align the set, you need a signal generator. And of course, the first thing you do is align the IF transformers. Now, if they are a mile out, it might be best to start and do the last one, the last IF first, and then move ahead and do the first IF transformer. Now if you want to do the last IF transformer, you take your generator and you connect it not to the floating ground, because you don't want live power going up into your generator. You connect it to the floating ground, you connect it to the chassis. And the other end of the generator is connected through a capacitor to the grid of the 12SK7. Now the reason for running it through a capacitor is you don't want to destroy any negative voltage on the 12SK7 coming from the AVC line. Because inside the signal generator is a resistance plot, just like a volume control, that is across the output of the signal generator. Now, when you're going to line the IF, you turn the volume of the radio up full, and you turn the generator down as low as possible, just so you can just barely hear the signal coming through the speaker. And if the oscillator is bothering you, you can come over here to the variable condenser of the oscillator, and you can take a jumper wire and ground it, short out the variable condenser. That'll kill the oscillator, and it makes it a little easier to align. So now we got the generator connected to the grid of the 12SK7 pin 4, and we're going to adjust the IF transformer on the right. And we can adjust the diode part first. Doesn't matter which one you do first. And then we're going to adjust the primary. And then we go back and do the diode part again. And then we go back and do the primary once more. Because sometimes one setting will affect the other one a little bit. So that should be now aligned to 455. You set your signal generator to 455 with a 400 cycle audio tone. Now you can move your generator from the 12SK7 over to the grid of the 12BE6, which is, I believe, is pin 7, and you can adjust the first IF transformer the same way. You may have to turn the generator down a little more now, because we got an extra tube, the 12SA7 or 12BE6, amplifying the signal, and we don't want it too loud, just so we can barely hear it. But always keep the volume of the radio at maximum. Now you adjust the first IF transformer the same way we adjusted the other IF transformer. Peak up each one and then go back and redo it again. And after you do that, you can go back and just touch up the second IF again too, without moving the generator. Just leave it where it is on the 12BE6 or 12SA7, and you can touch up the second IF once more. So there we have both of our IFs aligned.